Browsers have built more or less the same way for the last 15 to 20 years, without a whole lot of new architectural approaches. And so we stopped and stepped back and took a fundamentally different look at a web browser of how you would build a web browser in the era of cloud computing.
If you look at a typical browser today, it's based on the original browser designs from the mid-90s, back when the web was much simpler. We didn't have mobile devices. We didn't have large amount of content to the extent that we do today.
We were starting to look at kind of like the difference in between mobile devices and the desktop experience, and we noticed that there was just a very big gap between just the performance of loading a page. So what do customers really care about? It's the time it takes to get something that's usable on the screen. And so we really wanted to kind of remove those limitations by taking advantage of AWS services.
So when you think about different types of computers and different types of ways of accessing the internet, each form factor is meant for sort of specific capabilities, right? There's massive desktop, computers that are meant for really heavy-duty graphics processing, for example. But as you kind of go down the chain to more and more accessible form factors like a tablet, it's just not meant to do that sort of stuff. It's not meant to process and crunch a lot of heavy data, right? But when you add the capabilities of our cloud, where you've got EC2 instances with 68 gigs of RAM and 8 cores, and they're sitting right there on this massive optical network, they can take that work off. You still get the great form factor and the experience of the Kindle Fire, but you've got this huge amount of power behind it.
The biggest differentiator in our browser is the fact that it's split between what runs on your device and what runs in the cloud.
We've effectively taken a decentralized look at these subsystems. We split them apart, decoupled them, and we've placed all of these subsystems both locally on the Kindle Fire device as well as remotely on the Amazon Computing Cloud.
By building a browser that is smart, that is split between a front end and the back end, where the back end can do all those optimizations, we think really changes the game.
So with a typical web request on any normal browser, what you're going to do with every page request or with clicking to another page on the current site you're on, you've got to go out and do some DNS resolution. You got to go figure out where's the origin server, issue that request. There's sort of a TCP handshake that you ask them for the content that you want. It does an acknowledgement back to you. Bunch of back and forth steps to kind of boil it all down, right? Your device is going to have to go back and forth across that wireless network, perhaps dozens of times to get all the page assets. Now that's all time. Every time you're making a trip across the last mile and then waiting for things to get resolved out on the big internet, that's just time that the user is sitting there waiting. Each of those hops is going to be a minimum of like 100 milliseconds, right? Now when you think about a split browser where you're requesting assets from a browser that's running on the cloud, when also you can consider that a lot of those assets might in fact be living on the very same cloud, that's a 5 millisecond request. Now when you think about the 80-some files on the typical web page, that difference really adds up.
You can think of your web browser as a small store for some of the commonly accessed files that you use to browse the web. What we've done is extend that using the Amazon Computing Cloud to create a virtually limitless cache that can store the common files such as images, JavaScript, and cascading style sheets that are used to render the web pages you view every day. Because we've built this cache on top of the Amazon utility computing systems, it doesn't take a single byte of storage on the actual device itself, and that provides a much better user experience.
We can optimize what we're sending back to the device to account for screen size, pixel depth. So there's no point in giving you a 3 megabyte JPEG if it's going to look the same when it's 50K. And so we'll make that image 50K, and it'll get to your browser a lot faster.
The browser observes aggregate user behavior across a large number of sites. For instance, you might notice that people who view the New York Times homepage often go to the New York Times business page afterwards. Our browser is capable of detecting these aggregate user behavior patterns and actually requesting the next page you're likely to need before you even know you need it. We decided to call our browser Amazon Silk because really a thread of silk is an invisible yet incredibly strong connection between two different things. In our case, it's the connection between your Kindle Fire and the Amazon Compute Cloud. And it's the bringing together of those two elements to create a better web browser.
Because of the fact that Amazon was sort of the pioneer in cloud computing, that gave us a different perspective. It wasn't just about an application that sits on a device somewhere. It was about, let's build a whole new system. Let's build this split browser architecture that leverages this great strength we've got with our AWS cloud to kind of change the whole game and really rethink how do you do web browsers.
I'm sure you've had the experience where you've been trying to load a page and the browser's just sitting there hanging and you're like, oh, I wish I were on a better network. When we're on a better network. Our back end has some of the fattest pipes to the internet that you'll find. And we do all the heavy lifting on the back end and then serve optimized content over this dedicated channel back to your device. So you don't have to worry about it.
There's a lot of great innovations that we're really excited about with this new browser, and especially around the split browser architecture, all the stuff that enables with, image compression or predictive rendering, machine learning, all the great stuff we can do, optimizing the last mile connection between the device and our cloud. The great thing, in my opinion, is you don't have to think about any of that. It'll seem like a traditional browser, just a lot better and a lot faster than you're used to working with.